How you doing today? I hope you're doing well. Are you feeling better there, Khadija? I hope you are. Much, much better? That's good to hear. Good. Well, as long as you got Mr. Bex out of the way, then that's okay. In fact, I made a sandwich right before this, and I've been up since 5 a.m. Holy moly! How about me? Well, I've been up for a while. I have been. I won't lie. Let me go back to my thing here. Yeah. Oh, that's kind of dark. Oh, let me turn on another light. Oh. Ah, come here, light. Oh, hang on a sec. Gotta fix that. Okay. There we go. Okay. All right. There we go, ladies and gentlemen. Hello, hello, hello. Good afternoon slash morning. I think that's fine. Hey, Brian, how we doing today? Jess, how we doing today? We hopefully doing absolutely fantastico here today. Hopefully everybody's doing very, very well. Sitting and chilling, having a wonderful time. Just relaxing here, getting a little bit of math done. You know how it goes, everybody. You know how it goes. Look at all these fine people out here today. Very wonderfully fine people. How am I? I'm doing great. Look, there's only one thing that happened here today. So I was going to go get some breakfast, right, at Dunkin' Donuts. So I turned into Dunkin' Donuts, right, and I'm going to go through the drive-through. And then suddenly I hear a car screech and wham, hit another car, and I'm like, holy moly! It was like pretty close by to where I was. I'm like, holy moly! Well, I'm like, what just happened? So I see a guy that rear-ended another one, you know, and they had to turn into like a little shopping complex thing. It was like, oh, like I just hope that everybody was okay. It was pretty scary, but luckily it looked like everybody was just fine. Although the cars were pretty dinged up pretty bad. So remember, if you get into an accident, just be sure that your person is safe as opposed to the car. Okay, a car you can replace. Person is a different story. Okay, very, very important. I really need. I definitely needed my coffee. I definitely needed my coffee. That's for sure. Make sure the other's insured. That's right. Have your insurance, okay? Very important to have your insurance. All right? 100%. Be sure that you have your insurance. Because things like that, they can easily happen. Never take it for granted. You got a Spotify playlist or something? No. I do not actually. I have Spotify on my phone, I think, unless I uninstalled it. I don't remember. But well, yeah. This phone, man, this phone's starting to slow down a bit after X amount of years, but I'm gonna hold on to it for maybe another year before I replace it. So this phone is so good, though. I've done so. This phone has done so well for me. Can't really argue with that. Spotify is super good. Super good. Look at everybody here. Man, I don't know what it is about today. I don't know what it is about. I don't know what it is about today, but I feel pretty good. It's a good day outside. I ain't gonna lie. It is a very nice day outside. You know, it was super hot like a couple days back and stuff, but you know, I don't know how it's gonna. Yes, that's exactly right. You just don't know how, but you got that feeling on the back of your neck, which is not out of pure fear of mathematics, that it's gonna be a very good day. I'm not gonna lie. It's just that feeling right there. I like the vibe of this class. The vibe of this class here every time I walk in. Like dead serious. The vibe of this class has been so good, you know, this past week and a half. You guys really show up and you guys really help me a lot, you know. We get through these, you know, next couple hours, it goes by really quick, you know, and a lot of that has to do with you. All of you just doing, you know, absolutely giving me good vibes, giving everyone some good vibes. You know, just, you know, we're all sitting here together in a subject that can be really rough. I ain't gonna lie. But we've all been getting through it here together. I'm happy that everybody is here. So, the squad, yes indeed. So today I still have some coffee. I mean, nice and caffeinated. You know, nice and caffeinated here, Jess. Josie, hello, good morning / afternoon. Steven, good morning / afternoon to you as well. Lysa Rena, good morning / afternoon to you. How we doing here today, Steven? Steven, you're in a good mood as well. Steven, you're like, it's noontime, and you're like, bam, I'm gonna get things done on a Tuesday. I don't know what, you know, Steven, it looks like you're in like, you just like, boom, 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 gonna get some stuff done. Woke up with a lot of energy? Yes, that's what I'm talking about. Lots of energy. Absolutely 100% true. 100% true. Yeah, I was texting with a friend, you know, I was texting with a friend and we were talking, you know, we're just chilling and it's just like, you know, she contacts me here in the middle of the day, you know, right before I start class, and it's just like that extra energy when you're talking to a good friend and stuff. Jess says, say something nice? Absolutely. Jess, you are a positive member of this community. You should be very proud of yourself already for the contributions you have made. And I am very confident you will persevere. That is saying something nice, Jess. Thank you. Thank you very much. Danny, good morning / afternoon to you. Hopefully you're doing absolutely fantastic here today. All right. Yes, sir. That's how it rolls, ladies and gentlemen. That's how it rolls. All right. Let's go ahead and let's go ahead and yes, Blinky, yo, good afternoon slash morning slash afternoon, whichever way you want to say it. How you doing here today, Blink? Hopefully you're doing absolutely fantabuloso. Okay. Got Hey, no problem, Jess. Yeah, you asked. I said it. Bless up. Bless up for everybody. There you go. All right. All right. So we're about 12:02 here. All right. Let's do some intros here, ladies and gentlemen. We're going to go ahead and get started here with some new stuff. Let's do it. Yes. All right. Okay, let's get started today. Welcome back to Tuesday. All right, so we're gonna pick up where we left off here last time. Okay, last time we finished up most of section 2.6 here. We talked about compositions, functions here. That's where we left off last time. Now we do have one more part here to talk about from section 2.7, section 2.6, excuse me. One more question, and then we're going to go ahead and get into section 2.7. And if we have time, we'll get into section 3.1 as well, which is the next chapter over. Remember that the first test here is over chapters 1 and 2. I haven't quite finalized that test yet. I'm still working on paring down questions. It's been a little tough, to be honest with you. And I was dead tired yesterday. Like, did my second class and I just collapsed. I was like, let me go to bed for a while. And then I didn't wake up until 6. Like, okay. Guess my body really wanted to go to sleep. Like, okay, that's fair. Well, I woke up at 6 and then I waited for the plumber guy to come by. So, like, yeah, let me look at all the plumbing in your house, and then I was like, this plumbing in the house is pretty bad. I'm like, yeah, it's pretty bad, man. So, yeah, it's pretty bad. I ain't gonna lie. Plumbing in my house is pretty awful. So, hopefully that gets replaced. I'll actually have drinkable water for once. And then, yes, we'll be good to go. All right. Now, so let's go to the big board here. Having to fix house stuff. Yeah, you know what? I moved into this house here in 2015. I bought it for a steal. Like, it was a bargain. I had this apartment here was a complete bargain. So I got it for like $76,000. And so I spent like $8,000 on repairs because that's all I could really afford, because that basically spent like every cent that I had saved. And then now the plumbing after 6 years is starting to wear down, and it's it's time to replace a few things. So it's very expensive, but it was, honestly speaking, it was a long time coming. So look, to get a place that has 2-bedroom, 2-bath for $76,000 is an absolute amazing deal. Like, I'm not gonna, just let's not lie here. My home, the value of my house now is $125,000. So essentially, I've made my equity here minus the cost for repairs and whatnot, is nearly 50 grand. So I ain't gonna complain. I ain't gonna complain at all. So it's pretty darn good for a regular single dude like me. Yeah, I have HOA. Yeah, I have HOA because it's a condo complex, but HOA does a lot of good things here. So it's not like other HOAs, but this HOA is pretty good about things. So they do all the landscaping and stuff outside, and I don't have to do much. So just pay for electric. Yeah. If you wanted to sell right now, I could make a killing right now. That's true. Your boyfriend and I just bought a house a couple months ago, and we are doing the same thing with fixes. Yeah. Look, sometimes fixes are going to be piecemeal based on how much money that you have left over. So we don't know. Again, I knew how much money I had left over, and it wasn't a lot. So I have to do it piecemeal. Have to do it piecemeal. The market's nuts right now. Yeah, I know. But I like where I'm living right now because it's right between both of my schools. Before it would be like an hour-long commute. But if I do have to do face-to-face, at least I'm 15 minutes from Harper and like 30, 35 minutes from Elgin. So not too far from where I'm living. So otherwise, before it was terrible. So yes, indeed, winner, chicken dinner, exactly. I ain't gonna lie, that's true. All right, we gotta get moving here. I'm gonna talk about this all day. I'll teach you about mortgages and stuff. That's not a problem. If you want to know how mortgages work, it's actually fairly interesting. All right, anyway. All right, so today we're going to focus on one more problem here for section 2.6 and composition functions. So let's look at question 4 here, the last question from the last handout here. And that says, how do we find the domain of a composition function? All right, so I put a couple things here, but I'm going to show it in an example. So in words, it's pretty confusing, I understand. But when we actually look at an actual example, you'll see exactly how it works. So the note here, I said the domain of the inside function here is part of the domain of the outside function. All right, so the key here is to exclude any values from the inside function from the domain and find any additional values to exclude from the resulting composition. You're probably saying, whoa, 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 let's back up a second here. Back up the truck. I said, that's fine. Let's back up the truck. Let's take a look at an actual example here. And let's see exactly what we're working with when I put it down that note. I'm not going to disagree. That note is very is very difficult to kind of get to know, kind of get to do. All right. So let's go ahead and do this problem here. Now there was one problem I have. All right. So let's say this is going to be for number 4. This is problem 68 on page 310. So I'm just going to go ahead and copy this one down. We are given two functions here. F of x here is going to be 5 over x plus 4. And we're also given a g of x here, which is going to be 1 over x. All right, so this is going to be our guy here. And so let's take a good look here at this particular problem. Let's see what we're doing here. So first of all, it does ask us for two parts here in this problem. First, it asks us for FOG of x. All right. Now, if we were to do FOG of x, all right, that's going to be f of g of x, right? That's what we talked about here last time in terms of a composition function. So what I want you to do here, first and foremost, is to understand what the inside function is going to be. Because that, you know, if you look at the note here, it says, well, you have to exclude any values from the inside function. So taking a look here at what you see on the screen, which one of those functions is the inside function? Is f the inside function or is g the inside function? Is f the inside function or is g the inside function? All right. Good, right? That's correct. G is the inside function. So let's look at that first, okay? Because we need to exclude any values that do not work in the inside function. So G, let's at least put that down here. Let's rewrite that. G is the inside function. And that's just based on the definition of FOG of x. So if I can spell, let me know, because it's not happening for me today. So g is the inside function. Now, if you look at the domain of g of x, so look at g of x here. What's the domain of g of x? What values could you exclude from 1 over x? What values could you exclude from 1 over x in g of x? Let's at least put that down. 0. Okay, so Josie says 0. Lysadana says 0. All right, Carla says 0. Okay. All right, Brian says 0. Very good. All right. So 0 is absolutely correct, okay? All 4 of you absolutely spot on. So we know for a fact that based on the domain, x cannot be 0. We all agree that that has to be true. So anything else is fine, but it can't be 0. So whatever our result here for our domain for our composition function is going to be, we also need to take away 0 from that end result. So I'm going to keep that in mind here when we get down to the final domain part. Now, we do need to figure out what the composition is going to be. Let's go ahead and see what the composition is going to be based on this first part here. So f of g of x, I'm going to start from here. Again, that's going to be f of 1 over x. So that part is true. And so with f of 1 over x, you're just going to place 1 over x in every x in f of x. So again, if you need to draw a little arrow, draw that little arrow. Make sure it goes to that one guy right there. You're like, bam, there you go, you got it. So here we're going to have 5 over 1 over x plus 4. Okay, now we do need to clean this up here because we need to see a couple of things. So we're going to clean this up here just a little bit. As we see here, we do have a denominator here. This denominator here is going to be x. We're going to multiply by x over x here in order to get our common denominator. So what we're going to have here is we're going to have 5 on the top, and on the bottom here, we got this on the bottom here. We got 1 plus 4x over x. Okay, so I just found the denominator here, which was x here on the bottom part of this fraction, and then I kind of put it all together here, here at the end. Now, what you can do is, if you divide by a fraction here, you can just flip that fraction over. So you take that bottom guy, flip it up top. So essentially what you're going to get here is, just to show you the steps here, we'll get 5 times x over 1 plus 4x, and then we just smush it all together. And so our final result here, when we do the composition here, is that little bit of extra step there just to show you where I came up with that. I don't want to skip steps here in this case because sometimes that can be confusing about where you come up with that, but okay. So here we get 5x over 1 plus 4x. All right. So before I move any forward, is there any questions about how I found that? Any questions about how I found this? No questions? How'd I know g was an inside function? Well, basically what I do know here, E-man, is basically based on the definition of FOG of x. I basically exploited the definition of FOG of x. FOG of x is f of g of x. So the inside function is what's inside these parentheses here. That's how you know g is the inside function there, E-man. So therefore, you don't have to guess. Once you write down the definition of FOG of x, you'll know which function here is on the inside. Remember, order matters here. So if you wrote g o f of x, for example, E-man, f of x would be your inside function because you'd have g of f of x, and f of x would be inside those parentheses. So it just depends on which one they ask you, but that way you'll know which one's the inside function. Yeah, so that's why I went ahead and did that step first to define our inside function. Right, right. Any other questions? Just to clarify here, make sure we're all on the same page here. I haven't quite finished here yet, Blink. We're not even done with this first example, I promise you. We're getting there, though. We're not quite done, though. Because we do have to find the domain of this resulting composition. So, not quite done yet, but we'll see what we get here. So, B. I know, you're like, no, why do I have to do more? You're like, it's not fair. It's not fair. Okay. I'd be like, bruh, gotta do it. That's how it rolls. All right. So, what's the domain of FOG of x? Okay, what's the domain of this? All right. So there's two things that we have to take into account. Number one, we have to take into account that x cannot equal 0. So that part definitely has to be true. Let's look at the resulting. Hey, Gomesh, how's it going? Let's take a look at the resulting thing here we have for FOG of x. What number can we exclude from this particular result? What number can we exclude here in this instance? The 5x over 1 plus 4x. What number can we exclude there in this instance? 1? So 1 would not work? Think about it this way, right? If you take a look here, Brian, we have one function over another function. It's like a fraction, right? I don't know. I don't want you to guess. We're going to move away from guessing. I want some educated guesses here, my dude. Because the moment you guess is the moment it all goes wrong. So take a look. It's a fraction, right? Let's just go through it logically. It's a fraction. And we know in fractions you can't divide by what? What can you not do? It can't be 0, right? I agree with that, right? So let's look at the denominator, okay? Numerator of 5x, I don't care. That can be whatever number you want. But the moment the denominator is equal to 0, we're going to have problems. All right? So let's find out. Let's set this here. Let's say 1 plus 4x is equal to 0. Okay? Let's just solve for x in that case, and let's just see what we get. All right? So let's subtract by 1, that thing. If 4x equals negative 1, by 4, okay? Right? So that's correct. Here we get x is equal to negative 1/4. So we can exclude also x cannot equal negative 1/4. All right? So everybody sees how I got minus 1/4 there. All right? X cannot equal negative 1/4 because that's what makes that denominator equal to 0. All right? So we exclude two values here. X cannot equal 0 and x cannot equal minus 1/4. Now, because of that as a result, we're going to write down our intervals here. Again, you do have to express your answer even on the homework and the tests and stuff. You'll have to answer your results here in interval notation here. So if you have to put this in interval notation, well, we're going to need to go ahead and express that right now. So if we want to express x is not equal to 0, x is not equal to negative 1/4, let's take it a, yes, you see how it kind of makes sense now, right? So just do it this way. Here we got, real quick, why don't you cancel out the x's out over x? Oh, yeah. No, you only divide. So, Brian, you only divide out by the number. You don't cancel out the x's. Because what you want at the end of the day is you want x to be left over on one side, and you want the number to be over on the other side. If you cancel out the x's, you're just making more work, and really, it really doesn't do anything at the end of the day. So, because think about what you want there, Brian. You want x is equal to a number. That's what you want. So don't think about dividing out the x's. Yeah, don't trip yourself up over that. Know what the goal is at the end of the day. Goal is always going to be x is equal to blank. Okay, let's get x on one side. Let's get a number on the other side if we're going to solve for x. What? That's what we want. All right. Now, the way where this is going to go, I'll show you how to do this. It's actually pretty easy. Want to see a pictorial representation about how I would do the intervals. So I have negative infinity to infinity. I have 0, and I got minus 1/4. Again, I want to be sure that they are not equal to that. Okay. So real quick, what am I going to put? Am I going to put a parenthesis or am I going to put a bracket on 0 and minus 1/4? Parentheses or brackets? What do you guys think? Parentheses or brackets? I'm going to put parentheses or brackets next to 0 and minus 1/4. Remember, x cannot equal to 0 and x cannot equal minus 1/4. All right, so I see a mix of answers here. Okay, so I see some people say parentheses, some people say brackets. So let's recall here once again. All right, let's recall here once again. All right. Parentheses here means not included. Okay. Whereas brackets means included. Okay. So I don't want it to be 0, and I don't want it to be minus 1/4. I don't want those to happen. So in this case here, I'm going to need to put parentheses. Right. So based on that, based on how we actually do this out, we want parentheses here. So against next to minus infinity, there's always a parenthesis. Next to 0, I don't want to include 0, so there's a parenthesis there. There's a parenthesis. There's a parenthesis. There's a parenthesis. And there's a parenthesis. We're going to have 3 intervals here as part of our final answer. First interval here. We're going to use parentheses and use the U. Yes, that's correct, Jess. You have to put a U. Yes, between the intervals, we're going to put a U. So negative infinity to 0, and then put a U in front of that. And then you do 0 to minus 1/4, and then put another U. We'll have a third interval here from minus 1/4 to infinity. And there you go. We got it. So this is how we go ahead and express our final result here in this particular instance. Any questions about that? What did I... Hang on a second. Should we push the... Wait, what did I do? Oh! Ooh. That's kind of a problem. Well, that's kind of a... Note to self, nobody saw that. All right. None of you saw that. That's excuse me. Yeah. None of you saw anything here. Mean you're dumb? Be like, yeah, bro, totally am. See how I get this? You see what happens when you miss something? Oh man, I'm such a dummy. All right. Let me put that there. Good pick up there, Steven. I accidentally missed that. That's my fault. There we go. You saw nothing. All right. Just like you didn't see the just like you didn't see the rate my professor for me. Yeah, you didn't see that either. That adds some lots of lies in it. Okay, lots of lies. All right. Complete fabrications of. If you read rate my professor, those are complete fabrications. They're all lies. All right. You don't know. None of you saw any of that garbage. Okay. That was actually my chumps class. No. I knew it. I knew it. I knew it all along. I knew it all along. Ah. Yeah, I know. I paid a lot of people to put those things on. It was like the Yelp reviews of my cooking. Let me tell you, my cooking is just like my art, outstanding. You leave a 5-star review. No, all honesty, I don't pay a soul. I'm too cheap for that. If you did pick me based on what you read, well, I'm sorry to disappoint. Maybe. we're still working on it. I'm working really hard to make sure you leave me terrible reviews. That's what I'm working really hard to do. Hasn't worked out in 10 years, but I'm really working hard for it. There is a reason though. There is a reason, let me tell you. There's a reason, right? There's a reason. See, if you leave me terrible reviews, you know, if you leave me terrible reviews, see, that means that less people will sign up for the courses in the future, and that means I'll have just less to grade. It means less work to do. And it's just like, perfect. All right? You get that little sweet spot of having less work but still getting paid the same. uh Sadly, my classes fill up like crazy, so I'm. Jake. Oh, please be my guest. Rate me 4.99. That's perfectly fine, bro. Oh, I didn't fix the last fraction. You're right. You're right. This should be easy. Thank you. Whoop. All right, there we go. That was the rating I saw on the side up. Truth. All right. All right. Um. Yes, there is this. All right. That's not the best. Check that. All right. Okay, they're. You're 99.999% sure another math teacher had recommended you previously. Oh, okay. Do you guys get interrogated if your numbers are too low? Nope, not at all. Well, you gotta charge that up, Gold Mash. Get the charger, plug it in. Um, no, I don't get interrogated for that. So, if they're low, they're low. Again, it's a personal opinion. So, understand that people will usually put opinions like rate my professor, or really, they're kind of on never kind of in the middle. They're more kind of like, yeah, I really liked your class, or I really didn't like your class because of blah blah blah. So, um, you know, but I do read them on occasion there, because sometimes some people leave some good feedback, and I can be able to adjust from semester to semester. I do read, by the way, whatever your opinionaires is going to be here. Rate my professor is garbage. I mean, there's not. It's not like it's not bad. Like I liked it. I liked it. Uh, you know, it's not like you ignore the bad either. Sometimes you do something that could have made somebody mad, and you just had no idea. You're not going to get everybody. Everybody, you have to understand when you teach, not everybody's going to like you. Okay, it's like if you're even if you're a leader, not everybody's going to like you. Okay, that's just not how it's going to happen. Okay, I messed up by taking a great professor for the spring semester. Oh, I regret you. Oh, I'm sorry to hear that, He-Man. Hopefully this go around, hopefully it'll be a little bit better. But yeah, I don't necessarily ignore the haters either. Sometimes there's credence into them writing something. Maybe there's something that I did that I'm just not aware of. You have to take criticism also. So do understand, criticism is important. Okay. Students will rate you poor for making them work. Well, everybody's got to work. Everybody's got to put in the time and the effort and the work. Remember, you're working for yourself. You're not working for me. You're working for yourself. All right. If you don't like doing a lot of work and you want to coast, well, then you could go back to high school. But because real life, you can't really coast. Okay. You can try, but it's not really all that great. Someone nice. Hello, bro. Um. Uh. Now, high school is a completely different atmosphere. But once you hit a certain point, it's all you. It's all about the responsibility. It's all you what you have to do. So I've always expressed that here. High school is not high school's okay, but it doesn't. The problem with high school, in my opinion, um is that it doesn't properly prepare you for what you're going to be doing in the future. It doesn't properly prepare you for the real world, at least here in the United States. It's not it's not great. It's not great for that. Like it needs to be better, and unfortunately, it is not. So while you do want to go back to high school, is it going to be better for you in the future? No. At this moment in time, education is really broken. So I'm not going to sit here and tell you, yeah, it's the greatest thing since sliced bread. Yeah, you could have great experience in high school. There's people who have terrible experience in high school. I didn't have the greatest experience in high school, mind you. But you look back on it, it's like, you know what? I wish there was more practicality in high school than what they offered me. But really, a lot of high school is more about politics more than it is about education, and I really hate to say that, but it's true. Going to college, you're going to get a little bit more of that, dose of reality that you kind of need. So, um, Yeah, E-Man, hey, I want you to succeed. That's why I want to put you in a situation where you're going to actually use some of the information. I know that some of the things that I will teach may not use, but some of the things you'll be able to use. That's important. What's the funniest review you gotten so far, or the most bizarre? Oh, I could tell you that right now. That's easy. Funniest review I ever got, Jess, was there was asked a question on a student opinionaire. This was like 7, 8 years ago, and it was asked, well, how could you best improve this class? And the guy wrote on there, bacon cheeseburgers. That is what he wrote on the opinionaire. I looked at it. I looked at it, and I just said, yeah, that sounds about right. That's still even the funniest review I've gotten. The best way to improve the class. Hey, no problem. Or should talk to the Board of Education. Words of wisdom. Hey. It comes with experience and time. Wisdom comes with experience and time. That's what it is. And I will say this about wisdom as well. One other thing. You don't gain wisdom with age. You gain wisdom with experience. I was hungry. You gain wisdom. There's people who are younger than me who have a lot more wisdom in a lot of certain other things than I do. Understanding that age doesn't matter. It's about the experiences that person has gone through. So never discount a person because they're younger than you. Always take into account their wisdom from their perspective. Very important to know. Very important to actually acknowledge. So everybody brings something to the table that you could see things in a totally different line, in a totally different perspective, because nobody goes through the same two experiences necessarily. So always important to keep that in mind. Don't discount somebody's opinion because they're younger necessarily. Okay, that's not fair. That's why I see you as equals. I don't see you as like be lording over you. I may be in my 40s now, but it doesn't mean that I look at you like you're a bunch of teenagers. That's disrespectful and not fair to what you have to say based on what you actually have experienced yourself. And there are things that you have seen as individuals, as adults, that probably I will never get to experience or feel. And that needs to be acknowledged, and that needs to be recognized. What about students that are older than average students that you have? Yeah, I would view them the same way. They're my equals. My social psych teacher did that, and being almost 30, I would get annoyed every time. Yeah, look, everybody brings something to the table. Look, it's a point counterpoint thing, right? Me, I'm 42. I'll be 42 this year, actually. I'll be 42 this year. I'm born in 1979. Although not a lot of people believe that, but yeah. People look at me the first time with the beard, they're like, ah, yeah, he looks like in his 30s. Like, hmm. I'm like, I kind of laugh a little bit. Then when I shave my beard, I look even younger. All right, we got to move forward here. I'm talking like I'm like talking on the side here. All right, let me move forward here. All right, that's the first example. All right, we got to move forward. All right, let's move to section 2.7. All right, that's what's next on the agenda here, ladies and gentlemen. Yeah, I gotta stop digressing. It's one of my bad habits. I'm trying to teach you things. I'm teaching you like the other side of me. I'm like, but there's the math side I actually have to do. The dot dot dot, the part of my job that I have to do dot dot dot. All right. In any case, yes. So let's take a look at section 2.7. Now 2.7 here talks about inverse functions. All right. So let's look at question 1 here from the handout. It says, how do we find the inverse of a function? All right, so let's look at a function here. Let's see how we can solve for this, and let's see exactly how we can met that out. Now, first and foremost here, let's talk about the notation here, which you do see here on the screen, but I didn't quite actually show here. So again, the notation here specifically is going to be f to the -1 power, or we could just say f inverse. That's how we actually we write it, as f to the -1 power f inverse of x. But we say f inverse, just to indicate inverse here. Now, let's do an example here of if we're given a function. They say we give you a function. We say, all right, well, what is the inverse of that function? So we're going to follow this 4-step process that you see here on the left. All right, and we're going to see exactly how we can get this to work out. Now, this example, we're going to do 2 examples here, by the way. Start off with something easy, and then we'll start out. We'll try something a little bit tougher. Okay, so start off easy, try a little bit tougher, and then we'll see what we get. All right. So first one here is, let's say we're given f of x is equal to 3x minus 1. All right, simple enough, easy peasy lemon squeezy. All right, let's go through the steps here carefully one at a time, and we'll see exactly how things work out. All right, so step 1 here, if we're going to find the inverse function of 3x minus 1, the first thing that we're going to do is we're going to change f of x to y. All right, because f of x is the same exact thing as y. We talked about that when we first initially talked about functions. Well, y and f of x are pretty much one and the same, so we're just going to replace this just like so. All right, step 2. Step 2 says, next what we're going to do is we're going to swap all the y's to x's and all the x's to y's. So that's all we're going to do here. We're going to just change all the y's to x's and all the x's to y's. So automatically, this becomes x is equal to 3y minus 1. So that's what we do next, okay? Doing pie charts and graphs is boring. Well, I assure you, GoMash, this is a little bit more interesting. I assure you. Step 3 here. Step 3, we have to solve for y. So now that we swap the x's and y's here, okay, we want to solve for y of x is equal to 3y minus 1. So let's go through the steps here how we can solve for y. So what should I do first? How do I solve for y here? What should I do first if I'm going to solve for y? Add 1 to both sides. Sounds like a plan. All right. Agreed. So add 1 equals 3y. All right. Divide by 3. That's right. Okay. That is correct, Stephen. All right. So here we got x plus 1 over 3 equals y. Okay. Add 1, divide by 3. Yes. All right. So that is step 3. We went ahead and solved for y. Seems fair. Now for step number 4, all we do is make one aesthetic difference. That one aesthetic difference is we change the y to f inverse of x, and then that's the only aesthetic difference that you do. So here, our final answer is we change this y here, we'll change that to f inverse of x, and that's equal to x plus 1 over 3. I know I wrote this kind of in reverse, but I just changed this y to this guy. And this is the inverse of that function there. There you go. All right. Any questions about that one so far? That one's a pretty easy problem, but we're going to look at another one here, which be a little different, but at least you get the basic idea here. Any questions about kind of the basic idea? Yeah, where's the catch? Brian, I know it's been a week and a half. I've noticed your skepticism since day one. Rightfully so, mind you. Rightfully so. You're struggling already. Well, then, E-Man, you've been asking a lot of questions, and that's good. Okay. So again, feel free to ask me questions. Okay. If you don't understand something, that's why I'm here. I'm here to help you. All right. It's about you. It's not about me. Told you. So did X go to the left side? So did X get to the left side here? All right. So Joseph, what we did here in step 2 is we swapped out the x's and y's. So y became x and x became y. So anywhere we saw, since if you take a look at step 2 here, we're going to just change all the y's to x's and all the x's to y's. That's what we did here in step number 2. So I didn't move anything over to the left-hand side or right-hand side in step number 2. I actually just had to swap the variables and with x's and y's. That's what I essentially did. So that's why there's no that's why there's no movement necessarily in that step. All the algebra stuff is done in the next step over. All right. Well, let me answer Brian's question here. What's the catch? What's the catch? What makes this a little tough? Let's take a gander. Let's take a gander at this next example here. We need to take a different look. All right. All right. Yeah. Okay, so here's our function. F of x is equal to x plus 4 over x minus 2. We want to go ahead and find the inverse of this particular function. Okay, let's go through the steps here carefully one at a time, all right? Let's just go through it one at a time. I'm going to go slow here for this particular problem because I want you to see exactly what's happening here in the middle of this process. All right, so let's go one at a time here. Let's do step 1. All right, what do we do for step 1? What should I do? What do I do for step 1 here? Make them y, x to y? Is that what I do? I don't know if that's you follow the steps here. You're trying to skip. I don't want you to skip. First, change f of x to y. Okay. So this is what I want to do. I'm just changing this f of x. I'm just changing that to y. All right. So I have y is equal to x plus 4 over x minus 2. Again, I am very specific about that. The reason is because we want to avoid as much confusion as possible. So here's what the reason is because, okay, so the thing is about this is that I want to be sure that we take care of all the preliminary work before we actually do the main process. All right? This way, this reduces the amount of confusion and you're not skipping steps. Skipping steps, you're going to run into a bit of trouble because math is pretty inflexible like that. So, all right. Math doesn't like it when you try and skip. So, it's just part of the deal. All right. Let's go to step 2. Okay. So, what do I do for step 2? What do I do for step 2 here? So, okay, x to y. So what is it going to look like? So if I'm swapping x's and y's and x's, what is that going to look like? You guys tell me, what's this equation going to look like if I do that? I agree with all of you here. X is equal, okay, y plus 4 over y minus 2. Okay, Josie, be a little careful there. You have to have the x is equal there, Josie. So don't forget, we have y here off to the left. You have to change that over to an x as well. So here, that x is going to go here. We have y plus 4 over y minus 2. Okay? So just be careful about that. I just want to point that out so you're not skipping that part. Okay. Sounds great. All right. We're in really good shape here. All right, so this is exactly what we're after here, at least for the first two steps. So the amount of x's doesn't change anything, right? Actually, it kind of does. It kind of does. Kinda. Let me go ahead and demonstrate here. Because of this second step here, Blink, when we started off with two x's, now we have two y's instead here in step number 2. Because in step number 3, let's go recall here for step 3, it says to solve for y. Okay? So we got to solve for y here in this particular case. We got to solve for y here. So this is what we start off with. So let's take stock, right? We got x is equal to y plus 4 over y minus 2. I said that's fair. All right, but we need to solve for y here. So what do you think we should do first here? What do you think we should do first if we're going to solve for y in step number 3? What do you think we should do first here? I'll go ahead and rewrite. Move y over. Well, how do I do that? How should I do that? I'll times it by minus 2. What would that do? If I multiplied by minus 2, all I get is minus 2x here and minus 2 times y plus 4. That won't do anything, unfortunately. You can't, like, magically cancel out the minus 2. That's not how that works. Multiply the bottom. Multiply by y minus 2. Now, I could do that. I could multiply by y minus 2, right? That would get rid of my denominator. That's true. Okay, now Joseph and Stephen have the right idea here. We want to multiply by y minus 2 on both sides. Okay, so I agree with that first part there. 100%, I'm on board with this. Okay. I'll go to the all right. So I agree with everyone here. Oops, that's what I meant. Okay, that's fine. All right, Fritz, I'll take your word for it. All right. So let's take a look at what we have here. Now this y minus 2 and this y minus 2 will cancel out because that's what we wanted. This is what we have here so far. All right. I'll stop there for just a second. Okay. So what do I do next? Remember, our goal is to still solve for y. That's still our goal. FOIL, okay. That's fine. I find that to be fair. Let's just distribute. All right, so we'll distribute the x here to both terms. All right, fine. So here I get xy minus 2x equals y plus 4. Okay. Okay. I'm fine there. All right, so you would subtract 4. Okay. We just subtract 4. Show you something here for this. Probably saying, looking a little crazy here. Be like, yeah, maybe. Now, if I went ahead and subtracted by 4, this is what I would have. I'd have xy minus 2x minus 4 is equal to y. I got a problem. Here's my problem. I do subtract 4 on both sides. This is what I have. But I have a really large problem here. My large problem here is that I have y on both sides of the equation. That's kind of a problem. I can't have y is equal to something else in terms of y. That doesn't make any sense, right? If I find an inverse function, it should only be in terms of x. So I can't magically say that it's going to be equal to that because I can't have that happen. I can't have y on both sides of the equation. That's a big no-no. So this doesn't quite work the way you want it to. And I understand the reasoning behind why a lot of people said just minus 4 to end it. But I can't have y on both sides of the equation. That is not a thing, unfortunately for us. So what can I do? What else can I do then? How can I make sure that I get y on just one side of the equation as opposed to two sides of the equation? How can I get y on one side of the equation as opposed to two sides of the equation? What can I do here? And this is I can't divide by y. Unfortunately, that'll be a no-go. If I divide by y, then I have y over here on the left-hand side, and then I just have 1 on the right-hand side. Take x away from the xy and the 2x. I mean, I wish I could, but here we could I could do that. The problem is I'll get right back to where I started here from before, Carla. So I would be like, that's not a bad idea. Okay, that's not a bad idea. The problem is that I'll have y minus 2, and I'm still ended up with the same predicament as I had from before. I have some expression here of y minus 2, and then that's going to equal y plus 4, and then things get to be pretty messy. So it's not the worst idea, but I don't want to go backwards from where I started from. So I got to be a little careful about that. Again, not a bad idea, but not quite what we want to do here in this instance. I'll get a little bit of hint here because I know that a lot of people are kind of out of ideas a little bit. Yeah, I know this one's a little tough. I'm not going to lie. This is why I'm going really slow about this one here, because this is a good problem for perspective. All right, subtract xy. Well, that is not a bad idea. I kind of like that idea. That idea is pretty good. So here, let's do both of these suggestions that you guys had said before. Let's say I went ahead and I subtracted by 4. Okay, you guys said that earlier. But let's also subtract by xy on both sides. Let's say we went ahead and subtracted by xy as well. Okay. I know, divide by xy, maybe not. But let's do this. Let's cancel this stuff out. We'll cancel this stuff out. If I subtract by 4 on both sides, and I subtract by xy on both sides, let's see what happens in that case. Well, in this case here, what we get on the left-hand side is we get minus 2x minus 4, and we get y minus xy on the right-hand side. Now, I agree with that. Mr. George's suggestion is correct. You subtract by xy as much as you subtract by 4. Now, if you take a look here, look at this very carefully, right? You take a look here very carefully, notice that you have y's all on one side of the equation, and you got like all the x's and numbers, you got that all on the other side of the equation. Right? That's what does everybody see that? Does everybody see what we did there in that case? Not quite there just yet for the final result, but does everybody see why we went ahead and subtracted by xy there? Are there any questions about that? Yeah, go for it, Blink. Absolutely. You got a question, go for it. What about the x and xy? Wonderful question. We're actually going to go ahead and acknowledge that here. So remember, xy is just an expression, okay? xy is just like a letter times another letter. You can move that over as one term to the other side. So it's like if I had 6x, right? So think about it this way, Blink. If you had 6x, I could subtract by 6x on both sides or whatever, or 6y or whatever. That's basically what I'm doing. Imagine x was a number. You could still move it over to the other side. It's just a letter instead of a number. Okay, no big deal. I know this is pretty confusing here. Could we divide the x alone? In this case here, no. That would not be a good idea. To divide the x alone would be, you could do it, but it's going to end up to be really messy as a result. if you take a look at what take a look at the macro perspective here, Blink. At the end of the day, we want to have y's all on one side. Anything that contains a y, we're going to move to one side. Anything that doesn't have a y, we're going to move to the other side. So from a perfect macro perspective about what we want, because we want to have y is equal to something here, anything that contains y is going to be on one side. Anything that doesn't contain y is going to be moved over to the other side. However we go ahead and do it, we're going to go ahead and do it. All right? So if it has a y in it, that term has a y in it, shove it over to the other side with the other y's. Seems fair. So I want you to think through that perspective. That's what we essentially had to do. This is kind of like a tough thing for people to see it initially, but once you have that, that's fine. So y doesn't have to stand alone. No, not at all. Not yet. It will. As Stephen has pointed out here, that's exactly what we're going to do to make it stand alone, is to factor out the y here. But before we get to that point, we're going to shove everything that has y over to one side. So let me put that in a little note here. Okay. All right. So I just want you to look at it from that basic perspective here. And I know that's a tough basic perspective because it's not something that we usually do a lot of. So, but it is necessary here in this instance. All right, now Stephen has correctly stated the next step here. And the reason why we want to shove everything over to one side here is because of just exactly that. We can go ahead and now factor out a y here on this right-hand side. So if we factor out a y here, we get 1 minus x. And we get minus 2x minus 4 here on this side. Okay. So that's, honestly, that's the toughest part there. Once you get past that part, it's really actually rather easy. So, and then all you have to do here is then your last step here is to go ahead and divide by 1 minus x on both sides. You can divide by that expression. So your final result here will be y is equal to negative 2x minus 4 over 1 minus x, which then, of course, just change the last step here, which is just f inverse of x equals negative 2x minus 4 over 1 minus x. All right. How'd I get what there? Are you talking about how I got the 1 minus x here? So I factored out the y. So again, what's the important key here? Remember to. So important here. Let's put a little warning here. Remember to factor out a y. Okay. Factor out y. How'd I get the 1 minus x? Well, if you factor out a y, how many y's are left over? Well, y times what is equal to y? You get 1. If you take away y from xy, you get just x left over. So y times 1 minus x, that's how you basically get that to work out. So that was just strictly from factoring out a y there from that. And then we divided by 1 minus x on both sides to get our final result here for y. Any other questions? Gotta do it though. So much happened in like 3 minutes. I know. I know. But if you go over it carefully here, it's very important to kind of get to. And that's again, it is a tougher problem. That's why I showcase this problem here. Can you explain how you got the 1 minus x one more time? So again, let's go over this one more time here. This is what you started with here. You start with y minus xy. If you take out a y, if you factor out a y here, y times what is equal to y? Well, y times 1 is equal to y. Okay, so that's what you get here when you factor out a y. Okay, you get 1 here. So y times what is equal to y? If you factor it out, well, y times 1 is equal to y. If you take away a y here from this term of xy, then all you're left with is just x. The minus sign comes down automatically, but you just take away a y, and then you have x left over. And then that's how you get 1 minus x there. So it's basically the same thing as if you did this. If you had 6 minus 2x and you factor out a 2, you'd have 3 minus x. No difference about how you do that, right? If you wanted to rewrite it that way, you can. That'd be factoring out a 2. If you leave it at, no, that's not equivalent, no. You can't leave it as y times y minus x. That's not the same thing. Y times y minus x would be y, if you actually distributed it, right? That'd be y squared minus xy. That's not the same as what you have down here. You have to change it to a 1. Like you can't play loose with the rules here. You have to change it to a 1. What you see is what you get. If you're going to factor something out, make sure you look at what you have in front of you. You're trying to play it loose. You can't play loose with math. That's not how it's going to go. I know you really want to, but that's not how math wants you to do it. So, in that respect, you do have to be really strict about what you see. So, sometimes we can get away with it, but not in these cases. Especially when it comes to factoring, you have to look at every situation and see what you actually got in front of you. Hey, Formal Monkey. Hope you're doing good, my friend. Factoring stuff is hard. Factoring stuff can be hard. That's true. But the more you practice something, to be fair, the better you are going to get at it. Again, at first, when somebody sees this section here, usually this is kind of like the stuff where it starts to get a little bit tough. But once you get a little bit more practice with it, it's not so bad. Yeah, factoring can be really hard. Again, it's just practice. It's just practice. You know, it's just practice, my man. Always practice. You have a BS in math acting? Yeah, I agree. Some things are a pain to factor, I ain't gonna lie. Some things can be a pain to factor. You just have to be meticulous about it. That's the only bad part. Yeah, be really meticulous. All right. Be super extra detailed because math is one respect, I will say this to Monkey's comment there. Math is really super unforgiving when it comes to certain things. So he has a BS in math. He knows it very well. It's, certain things in math will not let you forget. Because if there's one thing in math that is absolutely true, is like if you do a problem in math and you get like the first like step or two wrong, it cascades to the rest of the problem. You get that horrible cascade effect, and you're like, oh man, I gotta do it all over again, sort of deal. That's a rough go. So we want to try and avoid those as much as possible. Sometimes, though, we get caught in that trap, but again, we want to try and avoid them as much as possible. So, you know. All right. Okay, let's take a look here at number 2. Number 2 is, how do we know two functions are inverses of each other? All right, so let's say we're given two functions here, and we want to find out if they're inverses of each other. Well, in order for us to do that here, we go back to the composition well here one more time. All right, and so basically that's going to be f o g of x is equal to x, and g o f of x is equal to x. So basically, if we take those two functions, we compose them together one way at f o g, we suddenly get x as our final result. And if we compose it the other way, g o f of x, we get the same result here of x at the end of the day. That's how we know that both functions are inverses of each other. Well, okay. You were like saying, well, all right, that's kind of okay. What does that mean? Let's take a look at some examples here, though, and let's see how we can work with that. All right. So let's do this here for number 2. And, all right. Yeah. So let's go with f of x here is equal to 3x plus 8. And let's have g of x here be x minus 8 over 3. Okay. So here we're given these two functions. Okay, we want to go ahead and see if these two functions are indeed inverses of each other. And we're just going to use compositions in order to do so. So let's see what happens when we go one way. Let's see what happens if we go another way. And let's see if we indeed get x here for both equations. So we're going to start off with f o g of x. And we're just going to test it out to see what value we get here at the end of the day. So again, f of g of x is f of g of x. Okay, just using the definition. So here we get f of g of x, which is that x minus 8 over 3. Okay, so that's that whole function there on the inside is x minus 8 over 3. So wherever we see x and f of x, again, if you need to, let's go ahead and underline that and draw an arrow about where you need to plop it in. There we go. We're going to plop it in right there. I'm going to get 3 times x minus 8 over 3 plus 8. Okay, so that's what we have here so far. Now, if we do the simple algebra here, these 3's will cancel out, so that's fine. And that leaves you with x minus 8 plus 8, and the 8's here will conveniently cancel. So that leaves you with just x. So this checks out here. F O g of x is equal to x. Perfectly fine. This is what we want to have happen here, at least one direction, all right, to get f o g of x to work out. Okay, seems fair. Now let's go ahead and try it the other direction. Let's try here. E-Man says hydrate. Absolutely, my dude. Thank you, good sir. Let's try it the other way. Let's try GOF of x. Let's see if we get the same result here. So we have g of f of x, so it's going to be a little bit different than we had before. This time we're going to have g of f of x, which is 3x plus 8. And again, if you need to, underline that 3x plus 8. You're going to place that in that x there in g of x, that guy right there. Okay. So what's this going to equal at the end of the day? Well, we're going to put in 3x plus 8. We're going to have that minus 8. All this over 3. All right. Oh, sorry. Apologies. My bad. My bad. I will, I apologize about that. That's on me. anytime I think, I have a friend. I have a friend who I called E-Man, who lives in Florida, and so I just kind of thought, oh, it's just like, oh, it's a guy. So it was like that's what I was kind of thinking, in all honesty. He's a nice guy too. He's down in Miami, but I met him in New York when he was living up there. So I get it. I've heard worse. Well, I'm just going off of basically based on my own experience. But hey, you know what? You've properly corrected me, so I want to thank you, my lady. There you go. If we're gonna be very formal about things, let's do it the formal way. You're welcome, of course. Question: why do we automatically move the three up? Are you talking about? Yeah, you're talking about this one here where we put it in for x. Again, notice that this 3x plus 8 would go in for this x into g of x. Yes. So that's why I put parentheses here around 3x plus 8. It goes into this x here. Okay? Because this is like a separate part. So now we did fog of x. That was one part. We had to show that that was equal to x if we plugged in that function in that with that ordering. Now we have to do it the other way where we do GOF of x, and we have to see whether or not this equals x if we put it in this ordering. Okay? So we're trying to figure out if this is going to equal x in this case as well. Because if, again, going back to the rule here really quick, they both have to equal x if we go both directions. Okay? So FOG has to equal x, and GOF also has to equal x if they are indeed inverses of each other. So again, if it helps you out, Blink, like if you're trying to just like write it out, just again draw that arrow about where you're substituting in about what you need to do for that problem. Right? Anything we substitute, we put parentheses around. Again, I'm keeping that consistent. That'll be helpful for possible sign changes. And that's what we're doing here for this one as well. All right. So in this case here, we get 3x plus 8 minus 8. So we get plus 8 minus 8. Those will cancel out. We're going to be left with 3x over 3. Give me just a second there, Jess. I will certainly do so. Here we get 3 over 3, and that's equal to x. So this checks out as well. Large check mark, definitely. So we have FOG is equal to x, and GOF is also equal to x. So at the end of the day, you can conclude, yes, they are inverses. Sorry about that. Over to the notes there. Out of this for a second. There we go. Are there any questions about that? All right. Any other questions before we move forward? Sure. All right. Oh, okay. Yeah, you don't want to do that. No, you don't want to do that. Again, why we put parentheses around there, okay? That way you can block that off, but you don't want to distribute the minus 8. We're not multiplying there. Yeah, be careful about that. Remember, it has to satisfy both, by the way, so don't forget the and here is important. It has to be both. If it fails one of them, then it's a no-go. They're not inverses of each other. So one way could be equal to x, but the other way may not work, which means, again, they may not be inverses of each other. They have to work both ways. All right, let's look at the next one here. All right. Next one here is, how do we know if a graph of a function has an inverse? All right. In this case here, instead of doing what we did here from determining if a graph was a function, in this case we did the vertical line test. In this instance, if we know if a graph of a function has an inverse, we basically do the horizontal line test, which is the same thing. In this case, though, instead of a vertical, we're doing a horizontal line. So we draw a horizontal line anywhere on the graph. If it hits 2 or more points on the graph, then the inverse of a function does not exist. Okay, so that's essentially how that's going to work. It's pretty much a horizontal line as opposed to a vertical line. So let's just do some quick ones here. I just write some generic graphs and you can tell me yes or no, it has an inverse or not. We're not trying to find the inverse of the graph here. We just want to know whether or not it exists, okay? Simple enough. So how about this? Yes or no, inverse exists. How about this graph? Yes or no, does an inverse exist? Okay, so the answer is no. That's correct. Okay, so if we draw a horizontal line here, we hit 2 points, unfortunately, on a parabola. The answer is no. All right, definitely not. Try another one. How about this? How about this? Yes or no? Straight up, straight line, nothing fancy. Okay, the answer is yes. That definitely has an inverse. I would agree. Okay, so you try the horizontal line. You're just going to hit 1 point. It is what it is. How about yeah, let's try another one here. How about yes? How about this? How about this? Yes or no? So if you draw a horizontal line, is it going to hit 2 or more points? If it does, then it doesn't have an inverse. So the answer is no. Okay, good. The answer here is no. Okay, so just be careful about this one here. If I drew a horizontal line and exactly on top of this one, it's going to hit an infinite amount of points. So that's definitely 2 or more points. So that inverse does not exist. Okay, so based on the definition of the horizontal line test, that's going to be, yeah, that's why it's that way. Okay, so all right, let's do one more. Let's do one more. About uh, how about this? How about a graph that looks like that? Okay, good. The answer here is yes. Okay, it's gonna only hit 1 point. You could try it out. You know, it's just gonna be like 1 point. Be like, all right, cool, you got it. Yeah. All right. Easy peasy lemon squeezy. All right. Let's do the next part here. Next. Okay. All right, so let's take a gander here at this next part. It says, what do we have to remember when graphing an inverse function? We have to remember when graphing an inverse function. Well, the thing that you have to remember here is we're going backwards here from your original function. That is from y to x in your xy chart from f of x. Now you're probably saying, whoa, time out. What are you doing with my life? Why must you make it so hard? Okay, now I'm going to show you a nice simple way to actually get the inverse function to come out from the original function. Now, we have a way to find the inverse function here. So this is not a problem to find the inverse function. We have our 4-step process that we talked about here at the beginning of this section. But I want to show you kind of an alternative way to kind of look at about how to do graphing with inverse functions here using the OG function that we have to start with. All right, so let's take a look at that here first and foremost, and then we'll take a look at how we can do the other parts there. Take away all this stuff. Oop. Bye. Okay. So let's go with, which one I want to go with? Yeah, you could find the inverse there. That's nice. All right, and so this one here is going to be number 39 on page 322. Okay, and we're going to start off with something nice and simple. Okay, so f of x here is equal to 2x minus 1. And they ask us for several parts here, so I'm going to kind of go over the parts here. Letter A is to find the inverse equation here. It says graph both the original function and the inverse function on the same grid, and then find the domain and range of the inverse here. So again, this one here is an easy one, so I'm going to kind of skip a couple of parts here first and foremost. What I'm going to look at here is we'll look at how to find the inverse here as the second part here, but I actually want to look at the graphs here first since that's the main highlight of the question. Now, the way we would look at this here, based on what we've done here so far the past week and a half, is if we're going to make up a graph for this guy here, we make a simple XY chart. So let's just go ahead and do that here. We're going to make a simple XY chart here, no problem. Now this simple XY chart is going to be, actually, let me move that down a little bit further. I'm going to make a little bit more room here, sorry. All right, so I'm still making the XY chart, just wanted a little more space. And this guy here is going to be just for f of x, okay? So this is just for our 2x minus 1, our simple guy like so. Now, let's start off with some numbers here, all right? And you guys help me fill in some blanks, all right? So let's start off with our nice number of 0, right? 0 is the easiest number we can deal with. Really no problems to deal with. All right, so if we plug in 0, what do we get? At least go with that. I plug in 0 here in this function. What do we get? All right, -1, right? All right, that isn't too hard, right? Simple enough, all right? Let's try another number. Let's try 1. Okay, let's try 1. We plug in 1, what do we get? Get 1. Okay, fine. That's fair. Okay, we try plug in 1, we get 1. Fine. Let's try 2. If I try 2, next number up, what do we get for 2? 3, right? Get 3. Easy peasy lemon squeezy. I'm going to try a couple other numbers here. Now these numbers here, I could try again -2 and 2 here. That's fine. -2, -1. I'm going to try, let's try this one here. I'm going to try -3. Be the last, well, yeah, we'll try this one. -3. If I plug in -3 in for x, what do I get for y? All right, so -7, right? Seems pretty simple, okay? You plug in -3, you get -7 back out. You're like, okay, I got it. It's done. All right, fine. Seems fair. Seems fair. All right, now, here's what I'm going to say about this. Now, you're probably saying, well, hold up a second. Why'd you choose -3? Well, I randomly chose -3 here. Now, you get a kind of an uglier number here, admittingly. Admittingly, you get an uglier number here because of -3. So that's fine. Now, you could put this on a graph. That's perfectly okay. And let's go ahead and put these on a graph here. Then I'll show you about f inverse here. So putting this on a graph here, not, not nothing too mind-blowing here, but let's at least establish what this line looks like at the very least. So get minus 3, 3, 4, 5. So here we got this. All right. So here, if we just connect the dots here and we draw the line out, I know it's not the most exact thing in the whole wide world, but no, it is what it is. There we go. All right, so there's the line here for f of x. All right, so this is the line here for f of x. Now, the one thing that I haven't done here so far is I haven't actually went ahead. I have not went ahead and found out what my inverse function here is yet. But I'm going to go ahead and find out at least the xy chart here for f inverse. So without even knowing what the inverse function actually is, I can actually determine what the points on the graph are going to be. And probably saying, well, hold up. How do I know that? Well, let's take a look. Let's make an XY chart for this. And what if I were to tell you that I do not need to guess in any way, shape, or form? Okay, there's no reason to actually guess here in this case about what my points are for f inverse. Now you're probably saying, well, how? How is that even remotely possible? Well, take a look back. I'm going to go back to the notes here for just a moment. I'll come back to this, come back to the guy here. So you're going backwards from your original function. So you go from y to x in your xy chart from f of x. So basically, here's what I'm doing, okay? Just to give you a proper context here. Normally what we do in any given function is we go from x to y. So we go from left to right. We plug in an x value here, and we go from x to y, okay? That's what we do here. What we do for pretty much every function for an xy chart. But if I want to find out my inverse function, all right, everything gets swapped around, okay? So put this actually in black here. In black here, we go here. We go from backwards here, in purple I'll put this. For our inverse guy, we actually go backwards here from y to x. That's right. So in this case here, this is for f inverse, we go backwards here from y to x. So essentially, if I do this, if I plugged in minus 1 into my inverse function here, what do I get for y? Let's do it that way. If I plug in minus 1 into my inverse function, what do I get for y? That is correct. Very good. We are going backwards here in this case. So 0, from going forwards here, 0 netted us minus 1. But now if I go backwards, minus 1 nets us 0. Fine. How about 1? What do I get for y? All right, we get 1 there. Fair enough. What would my next point be? All right, so 1 I agree. What's my next point? What's my next x value then? What's my next x value then? What should I choose here then? I should choose 3, correct, because I'm going backwards here, okay? So be a little careful here. I'm choosing 3, and what do I get back if I plug in 3 into my inverse? I get 2. That's right. Exactly. What should my next point be then? -7, that's correct. If I plug in -7, what do I should get 2? Should get -7, -3 here. Right. Oh, Jess is like the last question there. Okay, if we plug in 3, we get 2. That's right. I know your delay is a little bit longer, so probably what's going on there. That's fair. That's fair. I know what you meant there. Okay, so you can see we all went backwards here. Now I'm going to graph this in purple here, at least this particular part of the graph. Okay, so let's graph the inverse function here in purple, and let's see what we get here for our guy. So here we get -1, comma 0. Put a point there. 1, comma 1. We still have a point right there. 3, comma 2. Have a point right here, and we get -7, comma -3. 7, -3, right about here-ish. All right. We get this line here. No, it's not the most exact thing in the whole wide world. We'll just imagine it's. Um, there you go. And that is the line there in purple. That is going to be our inverse function right there. Okay? And that's how we can go ahead and graph our inverse function in this instance. All right, and if you want to go ahead and find your inverse function, that's not too hard because we know how to do that here. But you can directly find the graph here if we know our original function here, just by going backwards here. Okay. Okay, any questions about that? Any questions about that part there? Want to be sure everybody's kind of on board with that. I'm going to be doing a separate example for the next question, so because it'll make more sense than this one. So this one's kind of the easy one. This one's the easy one. We'll do the next one. Oh my God. Okay. All right. Now, the next part here I want to show off is this next question that we have here. This example that I have here that I just showed off is not the best example to use for the next question, so I want to pick a different function here actually. But let's talk about number 5 here, which is I think, yeah, that's the last question for this section here. Number 5 is, what is the domain and range of an inverse function? Okay. So because inverse function is kind of like, if you want to kind of imagine it as opposite, the domain of the inverse function here will equal the range of the original function, and the range of the inverse function here is equal to the domain of the original function. So everything is kind of reversed. Now you're probably saying, well, how do I know what that's going to be? Let's take a look at a different example here, and I want to just guide you through about how to find that here. Hey, Dylan, how you doing? Only to see you, mate. Hey, mate. Hello to you as well. I hope you do. Are you doing good, Dylan? I hope you are, my friend. Mate, I hope you're doing well. Um, Hopefully things are going well at school there, Dylan. Everything's going absolutely fantastic. Just chilling, having a nice time. All right. Let's take a good look here at the square root of x minus 1. Something very simple, okay, at least in terms of the function here. Thank you. Thank you so much, Dylan. Yeah, I'm doing absolutely fantastic. We get to cover some inverses here today, but most importantly, get to have some fun while doing it. And there ain't nothing wrong with that. So, the more fun I have, the better it is for everyone involved. Because all I do is goof off all day. So, it's kind of amazing, right? I have everybody here, and they're like, we get to pay you some money in order to goof off all the time and be like, bro, best job North America. Like, you teach some numbers here, here's some numbers, here's some money. I'm like, oh my God. Nah, I have too much fun. I have too much fun with everybody here in this class, man. And then this makes like afternoons so super enjoyable. Like everybody here, like dead ass, dead serious. You guys make this like super fun. So it may be a slugfest at times, but trust me, I like the fact that already in the past week and a half, we've made some really good positive progress on many fronts. I see it from a lot of you, by the way. So I've noticed uh, I've noticed trends and whatnot from you guys, and I'm really excited actually to see the progress continue moving forward here for the next few weeks, until the end of the summer. So very happy to see that. Um, okay, let's talk about the domain of this function here. Have you gained much following this? What do you mean by gained? I gain a lot. I don't mean like money or anything like that. No, I gain a lot of experience and I gain a lot of knowledge from everyone else around me. So a lot of people bring a lot of important things to the table. Definitely. Man currently stream lurking and found this. Hey, you rock for teaching this, sir. Hey, thank you so much. I appreciate that. I really do. I really, really do. Look at how look at all these people. They bring that the positivity comes from you guys. It comes from you guys here. I teach the material. I teach the material, but I'm a facilitator of information. But it's like the real changes that I see is not just the material. It's about the personal changes I see from every single one of these students here who want to better themselves at the end of the day. That's what a classroom should be about. It should be all about personal progress and trying to be better, trying to be a better person, whether that be in a knowledge or whether that be from a personal standpoint. Whenever you view a class like mathematics, whenever it comes down to a class like mathematics, sometimes for some people it can certainly be a gatekeeping kind of subject here because it's like, oh, I need to do mathematics as a requirement for my degree, but I'm really having a tough time with it. I'm really struggling with a subject like that. And believe me, I've then been through those kind of struggles myself. Um, but we want to make an experience which is going to be a positive one, where it's like, okay, it no longer has to feel like it has to be a gate kept course. It can be something that we can work through and that you can push through and hopefully make some personal progress as a result. And again, it doesn't have to move the needle a lot. It just has to move the needle somewhat, and then in that way you'll make the progress that you want here at the end of the day. So positive progress is exactly what we're going after here. Um, I know how tough it can be. I've been there, done that. So, um, yeah, I always think back to those times that I had. I want to be sure that everybody here is better for it. So, the vibes in this class is immaculate. Thank you. Thanks, man. Appreciate that. Yeah, we try to keep the good vibes here. That's important. That's important. 100%. 100%. Okay. Best level of math a few years ago, Hari, but hopefully it'll help you up. Yeah, you know what? That's important. Side question here: is the practice test out for this unit? Not yet. I need to pare down a few more questions there, Jess. I'm still working through paring down the questions here. I should have it done by the end of the day here today. So I will be putting out the practice test and the actual exam. So I'll have that ready here by the end of the day for sure. But yeah, there's just a few more things to actually go through. It's a lot of questions that I have to sift through. So really, I have to like basically take out a huge chunk of questions because I'm not giving you 125 questions. That's madness. So, um, yeah, you pass a level of math. Yeah, that's what I'm here for, to help everybody, move forward. Like I hate, like, the last thing I want to do is to gatekeep. I really don't want to do that. So I want to be a person that does gatekeep. It's really annoying. Better we make it a positive thing and make it a something that's walled off to you. So, all right. So here we got the square root of x minus 1. We have to figure out what the domain of the square root of x minus 1 is going to be. What is the domain of the square root of x minus 1? What's that going to be here in this instance? What's that going to be here? But by the way, if you're lurking in class there, that's perfectly fine. You can feel free to follow me. Anyone is welcome here at any time. Okay. So even if you're lurking around, you're more than welcome here to come back at any time. Any and all people are always welcome. So if you want to give me a follow, give me a follow, whatever you like. Okay. Totally, totally understand. Totally understand. So thank you so much. Thank you so much for the follow, Dina. Appreciate that. Feel free to stop on by anytime. Your presence is always welcome here in this class, 100%. X minus 1 is equal to 0. Okay, good. So let's at least start with that. I like where you're going with that. Again, this has to be true. Again, it has to be just equal. We'll set this equal to 0 here. So we'll just add 1 to both sides. So we know for a fact here that x has to be, in this case, equal to 1. That's our minimum value here. Again, you can technically put bigger than or equal to 0. So you could technically have bigger than or equal to 1 here if you want to say what the domain of this function is. All right, so because square roots, as we know, we can only take the square root of 0 and above. That's just how it's generally going to work. Now, the real question is that how do we go ahead and express that here as an interval? Don't you plus or minus with the square root? In this case, no. We just want to talk about the domain. What values that work here? All right, that's all we're talking about here. So taking the square root of a number here, we're only going to deal with the positive values here in this case. And I know that's very confusing, but some things will require both plus and minus. In these cases, we're only going to take the positive values here because the graph only requires the positive values. One of those very confusing things about math that is, I'll certainly acknowledge. It's very arbitrary sometimes which way you go, but I'll let you know which way we go. So that's why I always make a note, plus or minus is in play, or just positive values. So if we write this out here, it's going to be 1 to infinity, okay? 1 to infinity here is going to be the domain of this function here. What's the range of a square root function? Anybody tell me here, what's the range of a square root function? Okay, 1 to infinity is correct, Jess, for the domain. I agree with you. All right, so the range is the y values, the possible y values here. So what's the range for a square root function like this? The range here in this case, right? What are our possible y values? If I took a look at the graph here, say hydrate. Thank you, Blink. Let's take a look at the graph here of the square root of x minus 1. Negative infinity to 1. Take a gander here. See if that's correct. We have the square root of x minus 1. So there it is. Taking a look here at the possible y values. All right, just looking at this graph here, what's our range? What's our range going to be here? What are our possible y values for this graph? What's the lowest y value and what's the biggest y value? Go with that. Anybody tell me here? 0 to infinity. Okay, so we're talking about, all right, so 0 to infinity is correct, okay? Our lowest y value here, according to this graph, is 0 to infinity. Now, the one thing that we do have to be a little bit careful of, Lysanana, is basically we're going to put a bracket next to 0 because we actually have a point here in this case, okay? So we are going to put a bracket because 0 is actually included here as part of the range for this function. Okay, so the one thing we're just off about is just, again, that bracket next to 0. Yeah, no problem, no problem. Okay, so now that we know the domain and range of the original function, let's say we're looking at the inverse of this function. Again, we can find out what the inverse of this is. It's not too bad, but let's at least look at the domain and range here of the inverse of the square root of x minus 1. If we follow the rules here from the handout, we say, okay, the domain of the inverse is the range of the original. So what would be the domain of the inverse here? Oh, okay. Cool. What is the domain of the inverse function here? What would be the domain of the inverse function? I just switch everything. So you tell me what that means. I switch everything. What does that mean? I need to know your perspective here, Brian. Like you say, hey, switch everything. I'm like, that's cool. Tell me what that means too. Negative infinity to 1. We don't. Does that make sense? Domain of the inverse function here. What does that say? Let's look at that carefully. The domain of the inverse is equal to the range of the original. Is that what it says to swap it out like so? The domain of the inverse is equal to the range of the original. What's the range of the original function? What's the range of the 0 to infinity? That's correct. Okay? So read those rules carefully. That's why I put it there. 0 to infinity. That's correct. Again, this range here that we found just a second ago is going to be the domain of your inverse function. Okay? Because that's the rule here. Domain of inverse equals range of the original, of the OG. What's the range of the inverse function? What's the range of the inverse function here? What's the range of this function here? 1 to infinity. That is correct. Very nice. All right, now we're putting that together. There you go, right? Because that was the domain of the original function, but now that becomes the range, okay, of the inverse function. All right, that's all you got to do. So once you know the original function, you just swap them around in terms of where they go for domain and range, and there you go. Winner, winner, chicken dinner. Oh, thank you for the posture check, Blink. I appreciate that. And that's all you got to do. Simple enough. Excellent. Okay, and that is effectively the end of section 2.7. And the end of chapter 2. So that's the material done for chapters 1 and 2. We're there. Why do you use brackets again? Is infinity always? Yes, Stephen. Infinity is always parentheses. That's the rule there for interval notation. We use brackets when it's included. Okay, so brackets for included, meaning to say if you have bigger than or equal to, less than or equal to, you're going to use brackets. You strictly less than, strictly bigger than, you're going to use parentheses. So remember, we have x minus 1 is bigger than or equal to 0. So because it's bigger than or equal to, we use brackets next to 1. That's why we use brackets there. And the rule is infinities are always with parentheses. It doesn't matter. Whether minus infinity, plus infinity, infinity. That doesn't even make any sense. All right. To infinity and beyond? Indeed. Indeed. Buzz Lightyear would be proud of you. All right. All right, ladies and gentlemen, let's go to the big screen here. Hopefully, anybody has any questions here? Thank you for the hydrate. Thank you so much. All right, ladies and gentlemen here, I want to thank you all for coming on here to the stream once again. Let's go to the chatting page. Bam. All right. Thank you, and more thank yous to everyone who has come on here to the stream once again here for today for some college algebra action. You guys know exactly where to find me. I'm going to be here on Discord here for office hours today, or again, feel free to email me. I'm also available for some help if you need any. All right. Hey, no problem, Blink. I really appreciate that. All right. Thank you so much here. I love all of you guys. Everybody who's new here to the chat, thank you so much for coming on. And even if you're lurking around, thank you so much for even participating in a class like this. You guys are what makes this possible. Okay, all of you guys have brought the good vibes here today. I've been pleasantly happy here today, pleasantly surprised. You guys make the dream work. I ain't gonna lie. All right, trust me. You guys make the dream work. You guys make this. You'd make me happy at the end of the day, based on your personal progress. I'm very happy that in just a short amount of time we've been able to build such a good rapport with each other. Um, all right, but we're gonna be back here tomorrow, same time, same place. We're gonna start on chapter 3. That's the whole plan. We're gonna get 3-1, maybe a little bit of 3-2 here done for tomorrow. That is the effective plan. All right. Um, Last question. What is the brand of my headset? I need a new one, and the sound quality on yours is great. This is the XCloud Alpha headset. So you can get the HyperX Cloud Alpha headset here. That is the one I have here. Absolutely I do. So basically, this one here is like a gaming one. This has like a dual, it has a dual one. It has a chat function. It has 7.1 surround sound. You can adjust volumes for chat and game if you want to. The microphone is outstanding. The headphones are probably the thing that the leather stuff here on the sides are really super comfy. I've had a previous HyperCloud X. It was a different style, but it's always been super comfortable on my ears. So I always loved it, and highly recommend it. The price is actually pretty reasonable if you're into a slightly higher price. You're like talking like $100 or so. So pretty worth it, because my last one was like 5-6 years old before it broke, and then this one here probably is going to be like 5-6 years old before it breaks down. So one of the best headsets I've probably ever had for gaming, and for probably just speaking. So do you recommend we click on Ask My Professor for that specific question? Just ask me on Discord there, Luffy. All right. Ask me on Discord if you like, or again, email me if you have a specific question. Maybe it's late at night and I'm not responding on Discord. Just go ahead and email that, and I'll get back to you as soon as I check that there. You play WoW? Oh, okay. I make sure I avoid WoW. I'm just gonna be honest with you. I'm currently back into Final Fantasy. So I just went back to Final Fantasy not too long ago, because my friend got me back into it after a 5-year hiatus. So yeah, Luffy, just let me know, okay? Could I put the yeah, absolutely, yeah. Again, if you're not in the Discord, this is my link to the Discord there. There you go. You'll be automatically updated here in the Discord. That's an invite to my channel. So yeah, just click on that link you see right there, and then you'll be put right into my Discord. And this is my Discord here that I'll put on screen. Put that on screen. There it is. There's my Discord, and then your names will come up here, as part of being online and whatnot. There, I see Blink, you're on there. Okay, there you go. And see Luffy on there. Very good. All right, so I see Steven on there. I see Jess. I see, a lot of different people here. Again, if you need to ask me questions, I'll be on here. I get notifications on my phone and stuff. If you want to talk, we can do that. So that's not too much of a problem there if you have questions. So you got questions, I'll be more than happy to take them for you. This technically is office hours, so it's all good. It's all good. We're all here to help each other out. That's how it rolls. That's how it rolls in this class. Yes, yes indeed. All right. Okay. Hey Anna, how you doing? Anna, good to see you. How you been? I hope you've had a wonderful summer, by the way, Anna. I hope you had a wonderful semester with me last semester, but hopefully we'll have a wonderful summer, maybe being away from necessarily a math class. It's important for work-life balance. Okay. Your summer was good? Yeah, my summer was great. My summer was absolutely fantastic. I had a nice chance to relax for a few weeks and whatnot, but yeah, pretty, pretty fun. I ain't gonna lie, pretty fun. Now I get to get back in the swing of things here for the summer, and I get to even have more fun with all these fine folks, teaching some more math and enjoying our time here on Twitch. So get to have a little bit of excitement, 100%. See, we're all good friends here. We're all good friends. We're all good people. Yes. We're not all soldiers now, but we're all good people here. Okay, let me bring that up, Brian. I can bring that up. Let me grab that. Oh, yeah, that would be helpful. Would be helpful. You're off to class now? Just want yeah, stop by anytime, Anna. You're always welcome in here. You know me. I would never turn you away, Anna. Ever. That's how it rolls. All right, Brian, let me bring up your question here. And we could go over it together while I'm still online, so I don't have a problem with that. Dan, you have yourself a wonderful day. I'm gonna see you tomorrow, okay? If you don't, I'll see you tomorrow, or if you wanna, if you wanna hang around, you can. But whichever way. Have a great one, Josie. You take care of yourself. All right. Yeah. Let's just take a look. Why not? I can get away with it. It's not a problem. They're homework problems. It's no biggie. We have here, let's take a look. What problems you wanted again? 12, 15, 16, 17. Okay. Let's look at 12. Oh, right. I need to switch that up. Okay. Ba-bam. Let's do it. Alrighty. So it says use transformations of the graph here of f of x equals x squared to determine the graph of the given function here. Use the graphing tool to graph the function. Now, admittingly here, Brian, the numbers you're going to have are going to be different here, but the approach is just the same. You notice that, again, you just have to interpret this appropriately here based on the numbers that it gives you. Now, x squared is going to be your original function here. What we have to answer here, for example, in a problem like this is what the transformations are. So notice here we have a minus 5 here on the inside of this x. Again, that's going to indicate that we shift to the right by 5. All right, so we're going to pick here, if we want to use the tool here appropriately, we're going to go ahead and click on the parabola tool here. And we're going to at least pick 5, so it shifts to the right by 5, so 5, 0 here is what we have. So again, notice that this, you could click anywhere, actually. I clicked on that, but it says, okay, vertical stretch or shrink, horizontal stretch or shrink. Okay, and then it says, okay, vertical shift or horizontal shift. Now, in this case, it doesn't vertically shift since we don't have a number here on the outside. we do a horizontal shift here, which is 5. Okay, so we do know it goes right 5 for sure. So if you notice, the graph here moves. All right, and we vertically shrink or stretch here by a factor of 1/4. Okay. All right. So actually, let me check here. Let's at least check that here one more time, and that should be right. All right, and that should do it there. Let me check one more time. Yeah. Okay. So we have vertical shrinking here. So we want to go vertical stretch or shrink here by 1/4. Now I want to see if this is correct here actually, or we have to switch it. We have to do one more thing. But I'm going to go ahead and save this and check this here. All right, so that's correct. So we vertically shrink, horizontally stretch here. In this case, they want a vertical shrink here by 1/4. And then that's all you have to do there for that particular problem. And you'll get that correct. Okay? So if you notice how I wrote it in the notes, right? I kind of put, if you notice, just go with like vertical stretch shrink for the outside one here. And then in the inside here, they go with like horizontal shrink and horizontal stretch here. So, all right. All right, so that was the first one there. You good with going on to the next one? All right, let's move on to the next one then. That's 15, 16, 17. Okay. Okay, so use transformations of the graph to determine the given function here. So we have x squared plus 3. All right. So let's answer the question here. Which way are we shifting, Brian, for this function? Left 3? Well, be careful here, Brian. Notice this plus 3 is on the outside here. We have the original graph here. Oops, I picked the wrong graph. X to the third should be this guy. My bad. Let me clear this. Give me a second. I picked the wrong graph. It's this one here. Down 3. This says plus 3 here, Brian. What way are we shifting if the plus 3 is on the outside, Brian? Take a look at your rules there. If it's not on the inside, it's on the outside here. Up 3, that's correct. So we're going to vertically shift up 3 units. So we're just going to move this up 3 units according to that. We'll just hold that down. It says up 3 units. And that's all we want to do here for this problem. That is the transformation here for this particular function. We move up 3 units here. Okay? That's what we want to do here. Just because it's cubed doesn't mean it's any different. Again, the only difference is you do have to select this graph here, the x cubed tool. But the transformation rules also apply to x cubed graphs as much as they apply to x squared graphs. There's literally no difference. So just the one thing is, like, try not to make a mountain out of a molehill. You know, look at the rules, look at the list of rules, and try to memorize those appropriately. Yeah, because it's cubed, you do have to use that one. That's right. Right, so you have to use the x cubed tool instead of the x squared tool. Right. So there's a unique button for that. I will say that. Okay. Let's would you like to try the next one? All right, let's do it. Check this. I know that's right. The next one. All right, number 16 here. All right, so we have x minus 5 to the third power. So we're going to use the x cubed tool here. All right. Now, which way are we shifting here? We have the minus 5 here on the inside. So based on the rules here, how many units are we moving and in which direction? To the right, okay, so by 5, very good. So horizontal shift here to the right by 5. So there's 5 units here to the right. And there we go. You save this, hit check answer, got it. Easy peasy lemon squeezy. Nice. That is correct. Okay. Any questions about that one? Once you got those rules down, it's like, oh, that's not so bad. Yeah, it's not so bad. Bra. Bro, it doesn't have to be terrible, okay? I promise. I promise so. Promise you. Oh, okay. Wanna try the next one there, Brian? Got one more to go, so wanna do the last one, we can do that together too. Alright, let's do it. Alright. We got two things. Alright, so we have x to the third here, so we're gonna pick the x to the third tool. X cubed tool, we'll go ahead and click wherever. Alright. Let's take a gander at what we got here. We have plus 7 on the inside and plus 5 on the outside. Alright. So let's talk about units here. So up 5, agreed. Up 5, so let's move that up 5. And left 7, that's right. So if we're going left 7 here, we're going to pick minus 7 here for a horizontal shift because we're going left 7. And there we go. We'll save this guy. And we'll check it out, see if it works for this particular one. Yours has different numbers, but still, at the general gist. And we got it. Yes. Very good. Nice work. That wasn't so bad, right? Not the worst thing in the world. At least I hope not. No problem, no problem. I'm here to help. All right, any other questions, my friend? All right, no problem, Brian. Have yourself a wonderful day if I don't hear from you. All right? And as always, to everybody here who's left over, again, want to thank everybody here. Again, stay safe, stay healthy, everybody. And most importantly, stay sane. Have yourself a wonderful day, everybody. Thank you so very much, Steven. Thank you so very much, Brian. Thank you so very much, everyone here who came out for the chat. Thank you so much. You guys are legendary. All right. Have a great one, everybody. And we'll talk on Discord or wherever. Take care, everybody. See you later. Bye!